Bum bum bum. Well, here's the story. Tell how my life got flipped, turned upside down. I could take a minute, just sit right there, tell you how I became the prince of a town called Belair. Dun 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 dun. I forgot the rest. Fresh Prince of Belair. Woo! I was gonna say in West Philadelphia, born and raised on the playground where I spent most of my days, chilling out, relaxing, all cool, all shooting some b-ball after school, and a couple of boys who were up to no good started making trouble in my neighborhood. I got one little fight. My mom got scared and said, "Move it with your auntie and your uncle and Belair." Dun-dun-dun-dun-dun. I pulled up to a house about 7 or 8, and I yelled to the cab, "You home? Smell you later." I'm my kingdom finally there, sit on my throne as the Prince of Bel-Air. Woo! Watch Fresh Prince. Awesome show. Never saw it? Watch it. YouTube it. Cool. That's how Will Smith got started. Come on. Alright, thanks for being here. So we did 5 number summary. We learned about standard deviation and average and how that works. If you don't have any outliers, use that. So definitely go back and watch this video if you haven't. That'll help you how to calculate the standard deviation. Awesome. So next is the empirical rule or law, which applies to only mound-shaped distributions. It tells what percent of the data is found within 1 standard deviation, 2 standard deviations, and 3 standard deviations. So here's the empirical rule. So basically, if your center is always 0, and then depending on how far your data is spread out, you could be going 1, 2, or 3 standard deviations above the mean. So if you're 3 standard deviations above the mean, you're like in the 99th percentile, right? You just like got ACT score of 35 or 36. That's crazy. That's crazy. And if you only got your name right or only got one question right, even though you guessed on them all for ACTs or SATs, SATs or ACTs, then you're down here at the bottom 1 percentile. Wow. Okay. So as a rule, we're going to have about 68. This just works in nature, especially with humans. So we're going to have 68%, right? 34 plus 34. So 68% of your population are going to be within 1 standard deviation of the mean. So that means that so between 1 and -1. So -1 just means like below the average, right? If this 0 represents that 0 or the average, the center of our data. So then that means that anybody that's within 1 standard deviation above the mean, still pretty close to the average. Anybody that's below the below average, but just within maybe 1 standard deviation, yeah, more than 50% of everyone will be within 1 standard deviation of the mean. Everyone kind of clumps together. We like to do that. We're sheep, and we learn pretty well. So that's the average. Not too many high flyers, not too many low learners. Just kind of in the middle of the average, 68%. But what about 2 standard deviations? So that's almost everybody. 2 standard deviations is 95% of our data. So 68% of our data is within 1 standard deviation. 95%, let me just kind of say this, 95% of the population is within 2 standard deviations of the mean. And that means below and above, 2 below, 2 and above. That covers most of it. And then if you want to cover every single person nearly that you can find except for that person on a remote island that you'll never meet, that would be 3 standard deviations. Okay, so 3 standard deviations. So 3 below and 3 above. That's 99.7%. 99.7% of the population fall within 3 standard deviations. Okay? We learned how to calculate standard deviation last time. So say it with me. It's a test question. What is the empirical rule? What are the percentages of the empirical rule? 68, 95, 99.7. Woo! Crowd goes wild. So you want to memorize that. In fact, write it down 5 times. Write it down in your hand. What? Don't do that. Okay, maybe. So 68, 95, 99.7 rule. That's the empirical rule. Right? So that means that 68% of the population fall within 1 standard deviation. 95% fall within 2 standard deviations. And 99.7 fall within 3 standard deviations of the mean. Cool. So that's the empirical rule. It's going to look like that on the test. That's the empirical rule. So you know how to do that. It's just simple. Just memorize those three numbers: 68, 95, 99.7. So just to kind of give you the big idea behind it. So if you remember from our 5-number summary, when this was our minimum and this was our maximum, and then the middle was the middle of, or the median, sorry, was the middle of our box plot. And then do you remember what percentage of the middle of our data is? So that was Q1, the lower median, and then Q3 was the upper median, upper quartile, lower quartile. And so do you remember what percentage? So it was 50% with our box plot, right? Our median 5-number summary is 50%. Okay, so comparing that now to the average and standard deviation, it's not going to be 50%. It's going to be, for our kind of middle there, for one standard deviation, it's going to be 68%. Okay, and then it gets even bigger, and it goes to 95% next, right? And then this is just a visual display, so you can kind of see how this represents our data. And then nearly all the way there is 99.7%. And I feel like I'm missing just a tiny bit of red there. Yeah, it goes all the way to 3 standard deviations. And that's most everybody fall within either below or above the mean or right at the mean. Cool. So you want to memorize that for the test. Okay, next easy thing is to find the z-score, or standardized score. And so that's the person's score minus the average divided by the standard deviation. Okay, so when you're going to do a z-score, in this class, regular statistics, I'll give you the standard deviation, I'll give you the person's score, and I'll give you the average. You just have to do simple minusing, the difference on the top divided by the standard deviation on the bottom. Okay, so I'll give you an example. Ready? So here's how we do a z-score. And so a z-score would be, so let's say the SATs, right? I got 1050. So I had a parent tell me to guess on all the answers, and at the very end when we were running out of time. And back then you got penalized for guessing. Stupid. So that means that I got not the highest SAT score ever, but okay, 1050. Okay, well, to do a z-score, you have to have more information than that. You just don't want the person's score. You also need the person's average. Okay, cool. Well, so that's my score. And so the average SAT score was 950. Cool. And then the standard deviation was about 200. Awesome. And so that's how far it kind of spread out. Was the standard. It might even be 150 actually. I think that 200 is a little bit too high. Do you know what the highest maximum is for an SAT score? And so it's actually 1600. But we'll use a standard deviation of 100. Now, what was your ACT score? I'm listening. Shout it out, come on. Shout it out. I can hear a word you say. Oh, so what was your score? Okay. So, student score. Whoa, that's not going to work. Okay, so we'll say student score. Let's see here. So we'll say, I'll draw, this is you. Look, isn't that great? I'm so good at drawing you. So your score, let's say your ACT score, remember it's between 1 and 36. And so let's just say you had a score of 23? Yeah, good job, 23. Okay, and then what's the average? What does it take to get into maybe USU? So the average ACT score is probably 18 or 19. I'm going to be up to 20 now, but we'll say 18. With a standard deviation of, we'll just say 2. Nice. Okay, so again, what are we doing? What does the z-score actually do? So let's say that you're going to get into college, or me. There's only one place left, and I have an SAT score, you have an ACT score. They got to compare them. I won 1050. More than 23. Way bigger. Not necessarily. Got to compare it against the average, right? It's the person's score minus the average divided by how far the data spread. Okay, so what does the z-score even do? Oh my goodness, these scores are amazing because it lets you compare apples and oranges. You can't compare apples and oranges. You can with z-scores. So we can compare ACTs, SATs. You can compare how you did on your English test versus how you did on your math test compared to the rest of the class. And so z-scores are amazing. So we're going to now see who did higher, you or me. You or me. Hopefully me, but probably you. We'll see. Okay, so how do we do a z-score? So we'll just title this z-score U. We'll title this one z-score Newbold. And we'll see who had the higher z-score. Okay? And this is how you calculate a z-score. So you do the person's score, which is 23. Again, you minus it against the x-bar, the average. So 23 minus our average is 18. And then divided by 2. Well, 23 minus 18, what's that? It's 5. Awesome. That's an evil-looking 5. Okay, so minus 18 divided by 2. So that's going to be 5. And then 5 divided by 2 is 2.5. Wow, 2.5 standard deviations above the mean. Good job. Okay, then mine will be 1050 is my score. Minus the average x-bar of everyone that took the SATs that year. The average is 950. I remember, it was true story. Divided by a standard deviation of 100. Okay, well, 1050 minus 950 is 100. And divided by 100 is just 1. What? So that means that I got, nope, you. So you got 2.5, I only got a 1. So if we go back to our picture, like on our empirical rule, let me see here if I can find that, just to kind of show you. So I got a 1, you got 2.5, right? So this is me, here's Noobs. Yeah, Newbold. And then here's you at amazing 2.5. You did really good on your ACTs. And so we'll go ahead and say you. Lucky, you beat me. You're smart. Okay, so you got 2.5 on your standard deviation. So you're right here and I'm right here, and at least we're both above the average, so that's good. But you did better. You did better on your ACT. So with the homework, we're going to kind of pull stuff out of here. This basically walks you step by step, activity 5-6, SATs and ACTs. And so this will be the homework problems there that we're going to do with matching. And so we have a college admission, and we want to compare the scores of the SAT, Scholastic Aptitude Test, and then also took the American College ACTs test. And so suppose among those college applicants, we had a mean of a 96, so this is for the SAT mean. And so then if applicant Bobby scored 1080 on the SAT, how many points above the SAT mean score? So the mean was 896. So you're just going to do the Bobby 1080 minus 896 and put that answer here. This is really breaking the formula down, right? Just person score minus the average. Kathy did 28 on the ACTs. How many points with the ACT did she score? And so she scored above the ACTs. So the average for the ACTs was 20.6. So you're just going to do 28, her score, minus 20.6, and put that here. Awesome. And then is it sensible to conclude that since your A is greater than your B, Bobby outperformed Kathy? No, not necessarily. Right? Because it's out of different totals. And so that's why not necessarily. Because, just because she got that on the ACTs, well, compared to the average, maybe SATs they did better. So determine how many standard deviations above the mean Bobby scored by dividing your answer A, whatever you got for A, divided by the standard deviation, so which is also in here, standard deviation of 5.2. So take your answer from A, divide by 5.2, and that gives you your z-score. And so E is also asking for a z-score as well. And then which applicant had a higher z-score? It's either Kathy or Bobby. So that's going to be the answer there. Explain in your own words why the applicant you chose performed better on his or her admissions test. So you're just going to be able to maybe just choose a random answer, or not random, but a couple answers. Choose the one that makes more sense about average, doing better in her class or his class. Cool. Okay, so then we're going to have you practice it again, z-score. So then we're going to use the same average and the same standard deviation for two new people. So that's going to be Kelly and Peter. Okay, that's me. So Kelly and Peter. And so you're going to use the average for SATs is 896. The standard deviation is 174. And then the ACT average is 20.6 and standard deviation is 5.2. That's for the ACTs. Cool. Okay, maybe I'll underline those before I ship this worksheet off. That'd probably be a good idea to underline. What do you think? Okay, so we'll underline that one. And then we'll underline this one just so people can see those two things going on there and use those. Okay, so then we want you to find the z-score for Peter and z-score for Kelly, and then who had a higher z-score. And then under what conditions does a z-score turn out to be negative? So the answer to that, rewind this video and watch it. I said it back there when we talked about negative z-scores, so find that one. And then we want you to find the average standard deviation for these 5 numbers, 1, 4, 7, 9, 17. So that's also going to be on the Canvas homework assignment. Just one assignment this week for z-score and standard deviation. And then what mean score on the National News Standard was 75, standard deviation was 4. What would z-score for child 81 be? So that's finding a z-score again. And then finally, this is going to talk about the 3 percentages. So 68, 95, 99.7 are going to be the 3 answers. And so if I had an average height of 66 and a standard deviation of 3, what proportion of that would be between 60 and 72? So in this case, I just want to give you a last minute help there on this problem because this one's kind of tricky. And then you're done for the week. Thanks for learning statistics, standard deviation, and z-score. So basically, to help you out on this one, if it lets me, sorry this video is a little bit longer, just want to be really accurate and help you right on the homework this time, not let you suffer on your own there. So first, let me unhighlight that because that's might be the answer, might not be. Okay, so then there we go. So I drew a little picture here to help you. I'm actually just going to grab this problem and help you there. Keep watching, I'm helping you. Okay, there we go. So then, okay, so for this particular problem, basically we want to know if the stats class average height was 66 inches, which could be true, 5'6", with a standard deviation of 3, what proportion of the class are between 60 and 72? Well, if you put 66 in the center, and then you take the standard deviation, and you add 3 to it, that's going to be 69. And there we go. So that's one standard deviation, one SX or SD. They call it SD sometimes. So one standard deviation above the mean. If you add 3 again, 69, 70, 71, 72, then that would be 2 standard deviations, right? 2 standard deviations above the mean. And then if you add 3 one more time, you would get 75, which is 3 standard deviations. Now if you do the same thing, 66, but you minus 3, that would be 63, and then minus 3 again, that would be 60. And then minus 3 again, that'd be 57. Okay, do you see the answer now? Do you see the answer? So we want to know what proportion of the class has heights between 60 and 72. So if we're going to go from 60 to 72, that's going to be what? That's going to be 1, 2 standard deviations below the mean. And there's your hint, negative. And then 2 standard deviations above the mean. And so that's 2 standard deviations total. And you remember it goes 68, 95. So 95%. Awesome. Is our answer, which is E. Nice. 95%. Cool. So there's your answer on the homework there too. So thanks for watching this video and learning with me standard deviation and also empirical rule and also z-scores. So thanks for watching. My hat's off to you. Woo! Thanks for watching.